So we saw systems of equations with two variables and two equations, two unknowns. Now we have three equations and three variables. So there's Gaussian elimination is the process to solve a system of three equations and three unknowns. And the solution is going to be what we call an order triple, where we have x, y, and now we'll be talking about the z variable. So that's the solution to a system of three equations and three unknowns. So the number of possible solutions. The system that systems that have a single solution are those which after elimination result in a solution set consisting of an order triple, x, y, z. Graphically, the order triple defines a single point that is the intersection of the three planes. So instead of lines intersecting, we're looking at planes intersecting. Because 2 points make a line, but 3 points that are not on the same line will define a plane. And we have a nice graphic coming up about that. Systems that have an infinite number of solutions are those which after elimination result in an expression that is always true, such as 0 equals 0. Graphically, an infinite number of solutions represent a line or coincident plane that serves as the intersection of three planes in space. Or the systems that have no solution are those that after elimination result in a statement that is a contradiction, such as 3 equals 0. Graphically, a system with no solutions is represented by three planes with no point in common. So this first example here, we have like this plane here and that plane and this orange plane all intersect at one point. So that has a single point. In the second case, they intersect, but the result is a line. Okay. You might also run into a case where they intersect and it looks something like this. We got line, line, line. Here's the intersection, but you got two planes are parallel to each other. And then here's where they're all three parallel to each other. And so these wouldn't have a single point solution. Okay, so determine whether this point 3, -2, 1 is a solution to the system. So we have, let's put 3 for x, -2 for y, and 1 for z. We have 3 plus -2 plus 1. Is that going to be 2? So 3 plus -2 is 1. So 1 plus 1 is that 2? Yes, it is. 6 times 3 minus 4 times -2 plus 5 times 1. Is that going to be 31? So 18 plus 8 plus 5. Is that 31? I get 26 plus 5. And yes, that is 31. So that works as well. So 5 times 3 plus 2 times -2 plus 2 times 1. Is that going to be 13? That's 15 plus -4 plus 2. Is that 13? 15 and -4 is 11. Is 11 plus 2 equal to 13? Yes, it is. So 3, -2, 1 is a solution. Okay, how to solve a linear system of three equations, three unknowns. So pick any pair of equations and solve for one variable. Pick another pair of equations and solve for the same variable. You now have a system of two equations, two unknowns. Solve the resulting 2x2 system, as we did in the last section. Then back substitute the variables into any one of the original equations and solve for the missing variable. Okay, so we're going to look at this one, and if there's a typo, I'm pretty sure this is supposed to be an x here. And we have x minus 2y plus 3z equals 9, -x plus 3y minus z equals -6, and 2x minus 5y plus 5z equals 17. I think I'm going to go for that x to get rid of that first. So in the first one, I have x minus 2y plus 3z equals 9, and -x plus 3y minus z equals -6. So the x and -x go away. -2y and positive 3y is y. 3z minus z is 2z. And we get 9 minus 6 is 3. Okay, so there's one equation. Let's see what the next equation would be. If we take I'm going to take that second and third. I'll do 2 times that second one. So if I do 2 times negative x plus 3y minus z equals 2 times negative 6. And I'll pair that up with the 2x minus 5y plus 5z equals 17. So what am I going to have? I'm going to have negative 2x plus 6y minus 2z equals negative 12. And then I'm going to do 2x minus 5y plus 5z equals 17. If I add these together, I can eliminate the x. Excuse me. So negative 2x and 2x is nothing. 6y minus 5y is y. Negative 2z and 5z is 3z. And negative 12 plus 17 is 5. So now I have y plus 2z is 3, y plus 3z is 5. So if I take these and do y plus 3z is 5, and then do the negative of the one below, negative y minus 2z equals negative 3. So I can add these straight down. The y goes away. The plan was to eliminate the y. 3z minus 2z is z equals 2. Look at that. And put it back into either one. Y plus 2 times 2 is 3. So y plus 4 is 3. So y equals negative 1. Just checking with it. Yeah, it would be the same thing in the other one. So I think we got that part. So far we have negative 1 for the y. We have 2 for the z. Now we just need the x. So we could put it into either equation for the x. And I'll just go with the first one, I guess. So it's x minus 2 times negative 1 for y plus 3 times 2 is 9. So that's going to be x plus 2 plus 6 equals 9. X plus 8 equals 9. Or x equals 1. So that's it.